really challenging Aristotle ends up becoming tantamount to challenging the church.
If you have competing viewpoints, usually the simplest explanation is the right explanation.
I don't know if you can tell, but it's blowing around in the wind like a bouncy house.
It's never about intelligence, because incredibly smart people can believe incredibly bad ideas.
Have you ever gazed out into the world we live in and wonder what the world actually looks like? Beyond what we as a society were taught in school or watched on National Geographic, the Earth's true form has been a dividing question for centuries, and it intrigues the mind to think outside of the confinements of our societal and scientific norms. Entering the flat Earth conspiracy theory, many of us think that it is ludicrous or even insane, while others maybe think that it is the way that the Earth has always been shaped. When looking out at the horizon, it's hard to tell what the Earth actually looks like with the naked eye. Some believe that the Earth is shaped in a flat disk with an ice wall surrounding our oceans as it floats in a body of water. From the ancient Egyptian to Mesopotamian societies, the records suggest the shape is true. The Earth is a flat disk in an ocean with heavens above and hell below. The Iraqi tablets, Greek philosophers, and Norse mythology all pointed to the radical idea that the Earth is a flat disk. Delving deeper into this theory, we spoke with Dr. Ross at Longwood University to better understand the historical aspect of the flat Earth theory.
I know this is an argument that I know the Ptolemy gets involved in, the Ptolemaic Greeks. I mean, they were capable in ancient Greece / ancient Rome of conceiving of the world as a globe, essentially. There were arguments, and I'm going to forget the key figures involved in this, of a kind of flatter Earth, of an Earth that's kind of almost like encased in crystal, like an Aristotelian notion of different heavenly spheres that are almost like crystalline associated with each other. I couldn't tell you all of the names, but, of course, what's interesting in the ancient Greek context, right, is the only thing they really have to work with is a little bit of observation with the naked eye, but then mathematics, generally speaking. So it would make sense, of course, that you'd have these many different views in a world where the opinions can only be proven theoretically. Because it's kind of like a myth that Columbus and lots of people around the time of Columbus thought you would just sail off some cliff or whatever. That lots of people were working with the assumption that there was not a flat Earth. But certainly the age of discovery helps to take things from the level of theory and then to make it more kind of like empirical, to make it something you can verify now through observation, not merely mathematics. But in my intro history class, I don't teach about the flat Earth, but we do talk about the fact that at the same time as people in the 1500s are really discovering more and more, discovery is the wrong word, but going to other parts of the world, and so therefore learning about more of the world and the people in it. There is also this persistent, they use the word curiosities, which is to say, like, they imagine that people, that kind of monsters or mutants live in all different parts of the world. They especially think south of the equator that there are folks, what they would call the Antipodes, like, that there are like cyclopses and incredibly short, incredibly tall figures. And I do all of that to suggest that the more we're learning about the world, right, in some ways, it's not an overnight transformation. You can't expect all of a sudden Columbus sails the ocean blue and then people magically realize, one, I don't think lots of people thought it was flat to begin with, but it takes a really long time for those new discoveries to kind of filter throughout society and especially filter down to reach people and change their assumptions at the lowest end. Yeah, I mean, most people in like 1500 wouldn't venture more than 10 miles out from where they lived, and so for them it still would be a very theoretical kind of thing, right? It wouldn't be, I'm going and exploring the world. You're just hearing snippets of a news story that are probably snippets of a news story itself. Well, I can say more about Aristotle generally and how he shaped science and specifically the flat Earth thing, but this might be getting at the same point. So I mean, Aristotle's in many ways the father of science, really up until the scientific revolution. And that means both people take away from Aristotle like his direct arguments, which don't always get challenged despite contradictory evidence over time. This might be your Christianity side of it. Over the course of the Middle Ages, like Aristotelian science merges with Christianity so that things that really seem like outside the domain of the church or outside the domain of theology, like the position of the sun and things like that, challenging that, which is really challenging Aristotle, ends up becoming tantamount to challenging the church.
Yeah.
I mean, there's a lot more to say about Aristotle. Like, he does a whole lot of great stuff with the methods and instruments he has available at his time, right? But a lot of it has to become speculative.
Yeah.
You know, the scientific revolution is seen as kind of replacing Aristotle with like experiments, but also new technology like telescopes and everything like that. So, I mean, broadly speaking, like, he's the defining figure within pre-scientific revolution science.
While these are not the only people in history who have disproven the Earth being a spherical globe, the Bedford-Level experiment was conducted in 1838, which was a series of observations carried out along a 6-mile length to disprove the curvature of the Earth. Samuel Shelton founded the Flat Earth Society in 1956 and led this until his passing in 1971. Yet, it makes you wonder, what is the science behind this? We went to the Chichester building at Longwood University to discuss the physics behind the flat Earth theory.
The first time I flew to Europe, when I was right after I got out of college, when you look at a map of the Earth, it looks like you would. I left from Dulles Airport up in Northern Virginia to go to London. It looks like you would pretty much just head kind of slightly northeast across the ocean to go to London, but instead you fly like directly north up through along the east coast over Canada. Then you go up to Greenland and Iceland. And the reason that works is that you have to follow what's called a Great Circle, which is a circle that cuts through the center of the Earth. That's the most efficient path for an airplane to fly in. And so airplanes always fly that because, I mean, the Earth is not a perfect sphere. It's slightly longer in one direction than the other. So the technical name is an oblate spheroid, but it's like a basketball basically. And to get from one point to another on that kind of surface, you don't go in a straight line, really. You go in what's called a great circle. So that's another thing from my experience. I've actually seen the thing where a sailboat sails away from you and goes over the horizon. And of course, if the Earth was flat, the whole sailboat would get smaller and smaller and smaller, but instead, the bottom of the boat disappears while you can still see the sail. And the only way that could happen is if the sailboat is actually going over a curve, right? So I'm sure you use GPS, right? I use GPS. I mean, the way that works is that there are 24 satellites that are orbiting the Earth, and the way that they orbit the Earth, you're always in view of 3 of them at least. So if you step out here in Farmville, at least 3 of those are up above you, and the way that works is them circling the Earth in various paths. Let's say one other thing, we were just talking about, you and I were talking about eclipses. A lunar eclipse is when the Earth gets between the moon and the sun, and the Earth's shadow gets cast on the moon. And I've seen that a number of times. And as you watch the Earth start to cover the moon, the shadow is clearly curved, which is what a sphere would do if it was casting a shadow. So those are things from my own experience. Okay, when it comes to physics, I mentioned the Coriolis force. If you're going from here to there and you just set your plane's instruments to go directly south, you're not going to end up in Florida, because as you're flying, the Earth is turning. You're going to end up over here somewhere. Okay, that feels like something's pushing you that way. Really, nothing's pushing you that way. It's that you're flying straight, but the Earth is spinning. That effect is called the Coriolis force. It's the fact that if you move over top of something which is spinning, you don't end up where you thought you would end up. And so in the military, as I kind of mentioned before, when they shoot missiles or they shoot cannons, they have to adjust for that. The universe likes things to be spherical. Okay, if you look at raindrops and bubbles. You look at the moon, you look at the sun. The reason for that is that spheres are the most efficient shape that there is. And without getting too technical, basically a sphere has the most volume or space enclosed with the least amount of surface area. And that's the most efficient, lowest energy way to arrange things. And so nature loves things to be spherical. If you look up into the heavens, okay, the moon is obviously round, the sun is round. If you have a good enough telescope, the other planets are round. So one question would be, why would the Earth be flat and everything else is spherical? That makes no sense whatsoever. There's no reason for it to be flat. It's just kind of a silly. You don't find flat things in nature, really. And when it comes to gravity pulls everything toward the center. And if you watch things accumulate under the force of gravity, basically what's going to happen is they're going to start from a center point and build outwards. And as it builds outwards, it's naturally going to form a spherical shape where everything is exactly the same distance from the center. Physics would indicate that there's no reason for the Earth to be flat. In fact, there's every reason for it to be spherical. Until 400 or 500 years ago, people believed the sun revolved around the Earth. Okay, and then when humans developed telescopes and got a better view of what's out there, they began to realize their original view was wrong. Okay, and even then, if you go back, to the 1600s, they still believed that our solar system was all there was. Improve your view of things, your understanding of things improves. And so, to me, the idea that if you look around you at any point on the Earth and it looks flat, that the Earth is flat, is just a limitation of their limited view. You need to get a better vantage point and a more expanded view to get a more expanded understanding. And lots of people have been in space and looked back at the Earth and seen it. If you start off in one spot and you go off in this direction and you end up in the same spot, you must have gone around a sphere. Have you ever heard of a thing called Occam's razor? This is a long time ago. The bottom line of this philosophy is that if you have competing viewpoints, usually the simplest explanation is the right explanation.
While this is what we have been traditionally taught in school, through our textbooks and lectures, along with the societal expectation, David Weiss, a prominent voice in the Flat Earth Society, stated some controversy about these claims. What do you believe the Earth looks like?
Well, I can't get a full view of the Earth because we just don't have access. But if we go up to a balloon as high as we can go, 120,000 feet, it looks like that. It looks white, right? When you're up 120,000 feet, there's so much atmosphere, you can't really see the Earth. Unlike NASA shows us these vivid color pictures that are absolutely ridiculous. So I think the Earth is like a pond. And the shoreline of the pond contains our water. The shoreline of a pond has to be higher than the water to contain it, right? Because if it was lower, you'd have a waterfall, right? The water would go away. So the shoreline of our world is Antarctica. Antarctica is the highest land on Earth. Let me just show you what that looks like real quick. So this is just a little illustration. So here's our world. You got South America, right? Africa, Australia. And this is the shoreline of our world. Antarctica is the highest land on Earth. It contains our water. So that's kind of what it looks like. Question is, what's out here? What's out there? What's out here in the outer space? Well, I would say we all start out as realizing that the globe is scientifically impossible. The one that got me was that we can see too far. And I live on the water my whole life in the same town, pretty much. And the idea of seeing ships go over the horizon, and and then you could take today's modern optics and zoom them back in. And I was like, wait a minute, I can do this. So I went out and at the time Nikon had come out with the P900 super zoom camera, And I went out and I zoomed in on a buoy that should have been over 60 feet below the curve, and I could see it. So there's no horizon here. There's no boats on the horizon, right? There's no boats. As I'm zooming in, I'm making that bigger and bigger and bigger. And all of a sudden you go, oh, look, there is a boat there. So here's a boat that looked like it wasn't there, zoomed in on it, and it's there. And so if my finger can't hide that boat, but if my finger was a wave and it was closer, as that boat gets smaller, it could hide the whole boat. Where'd the boat go? Is it over the curve or is it just out of your visual range? It's beyond your horizontal eye zone. Yeah, there's very, very simple evidence. A ball is required to have a physical horizon at a certain distance based on your viewing altitude. Right now, the ball is hiding my mouth. You can't see it. And you can't zoom in on it because it's behind a physical curve. So the math on the ball that they tell us the Earth is 24,901 miles around says that at just 3 miles, there's a 6-foot drop. That means a 6-foot tall person sitting at the edge of perfectly calm water, that water should be curving away. And at 3 miles, there's a 6-foot drop. That means that there's a physical horizon that person can't see over. They shouldn't be able to see the surface of the water, and or as it goes farther away, it goes more. At 10 miles, there's 66 feet of curvature. That's a 6-story building. You can hide a 6-story building behind there. But the problem is we can see too far. And there's many, many, many real world examples. I showed you the boats. That's a terrestrial viewer looking at a terrestrial object. Another one would be this one here. This is a mountain. This mountain is 169 miles away. The top of that mountain should be like a mile below the curve. The tops of those mountains should be over 40 miles below a physical curve, but they're all there. They all line up right on a horizon. Why is that? Right? Does that mean the Earth is flat? Nope. It means the Earth is either flat or 1,000 times bigger than they tell us. If it's 1,000 times bigger, maybe there's 1,000 other continents that we don't know about where freedom can reign, right? Resources. What are all wars about? Power, resources, land, right? What if they're hiding more land? So when you start looking at these things, the rabbit hole just gets deeper and deeper and deeper. The question is, why can't we see some things that should be there? Here's a spot from Aluja, France. 175 miles out here is a mountain called Mount Canigou, and you can't see it. Why can't you see it? Well, the light that's bouncing off of it isn't strong enough to push 175 miles away. But twice a year, as the sun migrates in between the tropics, it's lined up with the viewer and the mountain. And as it goes into the distance, it backlights the mountain. And all of a sudden, you can see the whole mountain. The very top of the mountain here should be over a half a mile below the curve from this viewing spot. But twice a year, you can see it. They want you to believe, they teach us that all the planets, they go around the sun, but in their model, the globe model, the sun is moving at 500,000 miles an hour. So it's all chasing the sun. We're traveling 4.4 billion miles a year. It's a huge number. Never to return to where we were before. And somehow everything remains in perfect timekeeping order, perfectly, right? None of the stars ever change. They're always the same. Go out tonight, take a picture of the stars, put a note in your calendar to do the same thing next year or in 10 years, and every star will be in the same place, even though we've gone trillions of miles. Polaris is, right over the North Pole, right? And so everybody in the upper part of the world, the northern part on the globe, can see it. That makes sense. It also makes sense on a flat Earth, right? If it's at 0 degrees latitude, once you're beyond the equator on the ball, there's no way you can see Polaris because there's a physical obstruction. It's too low on the horizon. But the Polaris has been spotted as far as 30 degrees south. That's impossible on a ball. Impossible. And it's the only star that's stationary. Right? With all of this going on, Polaris never moves. From here to here is 186 million miles, just so you understand. So in Georgia, not too far from you, there was this monument of these stones with the 10 commandments on it, basically for the New World Order. That's a whole nother topic. But the center stone had a little hole in it. And you look through it, there's Polaris there every day, every year, never changes. So the Georgia Guidestones were built in 1981. They say the precession of the equinox, I don't know if you're familiar with that, is the wobbling of the earth. And it takes 26,000 years for a full wobble. And that means it's moving 1 degree every 76 years. 1 degree in the sky is 3 wisps of a full moon. Okay. It was built in 1981. It was up for over 40 years. That means it's moved a half a degree. A half degree is 1.5 moon lengths. That star would have been out of there. We had one of our guys did this experiment. So it did it at night, cold on a frozen lake. So it's freezing, right? You got to remember that. And so he's out there. He's got his snowmobile. He's got his camera set up 6 inches off the ice, right? And he set up these 4 lights at 8 miles, 7 miles, 6 miles, and 5 miles. At that height, according to globe math, there should be 30 feet of curvature. This one should be hidden, remember? Hidden behind curvature, 30 feet, 22 feet, 15 feet, and 9 feet. But they all magically show up right on the horizon, right there in a straight line. They're all refracting up at their own amounts, right? That is what I call impossible. It's about controlling your mind, right? So as a child, you're taught that the earth is a ball, and you try taking a ball away from a baby, it doesn't work well. Try taking a ball away from a grown man, that doesn't work well either, because your whole foundation's built around that, right? So I don't know if you can tell, but it's blowing around in the wind like a bouncy house. And watch right here. You're going to see a tissue in 5 seconds go by. Watch, a piece of tissue. Ready? Here it comes. See it? That shows you that it's just floating in the air. See that? What was that? We're like, what was that? So we took that clip, we slowed it down. Kind of looks like some sort of quadcopter or something, some sort of, cloaked plane. I turn it sideways. Let me crank up the contrast. And there it is. That might be some sort of blimp recovery vehicle. And it accidentally got filmed. There's no explanation that they have.
This leads the mind to wonder, is this the true shape of the Earth that has been hiding from us for so long? After speaking with Micheal Marshall from the Good Thinking Society, which is a non-profit organization from the UK, its goal is to encourage curiosity and promote rational thinking, providing insight into a more rational way of thinking in this flat Earth dilemma.
I mean, first and foremost, I think the world isn't flat. I think it's the spherical shape that science strongly suggests that it is. And so I find the flat Earth conspiracy theory fascinating as to how people end up believing in something that is so comprehensively rejected by the rest of society. And I think it's kind of a sign of the kind of forces in society that can lead people into these niche channels. I start to see that actually it's not just that these people think the world is flat, they actually have an alternative version of reality in many ways. They subscribe to a cluster of alternative ideas, some of which are incredibly harmful. And so speakers at the Flat Earth Conference, they'd be talking about how NASA is hiding the truth of the flat Earth, but they would go further and say who are the shadowy forces behind NASA and who is the global cabal that is running all of the one world government. And, this very quickly slips into anti-Semitic conspiracy theories and all sorts of things. Of all their beliefs, the flat Earth is just the most visible, but it wouldn't take much for that to change. It would only take a small change in society for their more harmful beliefs to come to the fore. And then when COVID happened, suddenly we found that, they also had some very strange views about virology and vaccines and things like that. While it might seem from the outside like this is a relatively harmless idea, it's even things that seem silly and trivial can be markers of something more serious, and you have to kind of try to protect people from slipping into very dangerous patterns of thinking. I think the most striking thing that I found, and this won't be true of every flat earther, but it was certainly true of a majority of the people I happened to speak to when I was at the Flat Earth Conference, and every single speaker, pretty much. At one point in their talk, they would say, I was going through a really bad time in my life, and then I realized the world was flat. And people would list a midlife crisis, a health crisis, a relationship breakdown, losing a loved one, losing their job, just different crises that had impacted on people's lives. And without even just casually, they just mention this as part of their journey. But I think it's not a casual part of their journey. I think it's quite a significant part of their journey, because I think when we're under duress, we turn to simple answers for complex problems, and then we also have the effect of, I guess, being able to find anybody online who agrees with you and being able to form a community around a belief. You have effectively a sort of group polarization happening. And a group polarization is this idea that if you get people together who share a belief, I'd say a 7 out of 10 on the spectrum of whatever particular idea in terms of their strength of belief, if you get a load of 7 out of 10s together and just put them in a room by themselves, they don't stay at 7 out of 10. They get more and more extreme because there isn't the rest of society to anchor them back to 7, and they'll go to 8 and 9 and 10. And I think we see that polarization in the flat earth. And we saw that as people spent more and more of their time in online communities where the only people they'd be talking to would be other fellow believers. And so they would start to transition their social life into these communities. And I think that was a real risk factor, because it also means that if someone in that community does have anti-Semitic views or believe in some pretty dangerous ideas, it's much harder to reject them because you've already rejected your mainstream community. You've found yourself at this new community. Can you reject that community if it starts to go bad? And if you do, where are you going to go next? And then I think the final factor that is a huge part of the story is the way in which technology companies were actively directing people to this material. Almost to a fault, I would say every one of them will tell you YouTube is what got them into it. Or, they spend a lot of their time on YouTube. And it wasn't because they went looking for a flat earth video. It's because at the time, YouTube just wanted to keep them on YouTube and would start floating them videos to say, what about this? Are you interested in this? And the problem with flat earth videos is a lot of people will click them because they'll think they're ridiculous and silly and want to point and laugh at them. A lot of people will click them because they're researchers who want to methodically take down every single point that's made. And some people click them because they believe them. And there's people who might just click them out of curiosity. But YouTube can't distinguish those 4 audiences and just saw this as one big audience. So this video clearly is something that a lot of people are interested in. So I'm going to recommend this to more and more people. And we see a similar thing with Facebook in the way that it was promoting people into pages and groups. Any group that had a lot of engagement, a very active community, a lot of kind of comments would be pushed up the ranking and pushed towards people. And so Facebook was saying, hey, you might be interested in becoming a flat earther. You couldn't just say, yeah, but here's a scientific proof that the world isn't flat. That wouldn't ever change people's minds because it wasn't a scientific proof that got them in. And now it's so core in their identity, you can't challenge their identity with a fact. Firstly, it's that people would assume they knew what the flat earth theory was. So people who are aware that the world is spherical would say, well, flat earthers, they're stupid, they're gullible, they're all these things. I don't think they are. It's not about intelligence, it's about something else. But they would assume that anybody who thinks the world is flat must be stupider than I am. And so they would assume I know exactly what worldview they believe in. But what happened was, the more I talked to flat earthers, the more I realized that they don't have one single version of the flat earth. There are some who believe that there is a disc, like I've got over my shoulder here, a disc with a wall of ice around the edge, with with the Arctic Circle in the middle, and everything sort of spread out. But there's other people who believe that instead of a disc, there's just an infinity of ice in all directions, and that the world is this plane of existence that bisects reality, that it just goes on forever in all directions, and you can't get below it in any kind of way. And they believe then if there is this infinity of ice and we're basically in a pool in the middle of it, then over there on another part of the ice there may be another pool, and that's where aliens come from. And so they start to put in their alien kind of beliefs as well. And so you'd find people who were trying to persuade people out of the flat earth movement, if they hadn't listened to what the flat earth movement actually believes and what model they have in their heads, they were just ineffective because they were arguing with a straw man because they weren't listening. And going along to the flat earth conference, what I found was speaker after speaker would get up and talk about a different, just coincidentally, it wouldn't be a central part of what they were talking about, but the worldview, the shape of the world that they were describing would be different from the previous speakers. There's one speaker who got up and explained that the world is a diamond shape. With the equator being at the right across the widest part of the diamond, and the North Pole being the point at the top and the South Pole the point at the bottom, and that can explain why getting from point A across near to the pole takes a much shorter time than getting A to B across the equator. So that would make sense. But to explain it, he said, along the edges, if you travel too far in one direction, you don't fall off the edge. You go through a 4-dimensional time-space warp, where you go through that and you appear back on the other side, and you can carry on just traveling forever like a kind of computer game, like Pac-Man or something like that. And nobody in the audience batted an eyelid at this. And then the next speaker got up and talked about how the world is disc-shaped again. And it occurred to me that it's because for flat earthers, it didn't matter what version of right you were, as long as you agreed that everyone else was wrong. You could have any different shape of the world that you wanted, because all you would talk about are the ways in which the rest of the world was wrong. It wasn't about putting forward an idea. It was about rejecting the mainstream idea. And so that was such a huge part of it. And then the other part of it that really surprised me, but then the more that I spent looking at the history of flat Earth, it was less surprising. But it really surprised me how much of the flat Earth belief was wrapped up in a very evangelical form of Christianity, all to the point of creationism. So that the world is 6,000 years old and was created, as the book of Genesis says, within the space of 7 days. Until I started researching the history of it, and you actually discover that Samuel Rowbotham was one of the first modern flat earthers. He wrote the pamphlet on whose work many flat earthers today are still basing their arguments. But he wrote it explicitly to reject the ideas of Darwin at the time. This was a way of proving Darwin wrong, because if I can point out that the world is flat, and then I can point to parts of the Bible that suggest the world is flat, I can say the Bible is right about that, and therefore it's right about evolution, well, right about the creationism rather, and so Darwin was wrong. So that modern flat earth movement was founded on a rejection of evolution and a forwarding of creationism. Fundamentally, the flat earth model just isn't based on anything scientific at all. It's based on picking at perceived inadequacies with the real model, but without really fully understanding that. So why would it be in a flat Earth that if you're stood in Australia, you can see the Southern Cross? If you stood on the opposite side of the disk, furthest away, you can see the Southern Cross, but the bit in the middle, you can't see those stars? Why aren't you looking at a consistent set of stars right across the entire disk Earth if it's a flat disk looking out at the sky? It makes no sense. It only makes sense if you have a spherical version of the Earth. I think in these situations, it's never about intelligence, because incredibly smart people can believe incredibly bad ideas. And unfortunately, they're really good at believing bad ideas because they're smart enough to find justifications to themselves. So they can be very effective at that.
After speaking with these individuals, there is a clear divide in what the population believes that the Earth's true form is. Amidst this conflicting ideas of what the true form of the Earth is, what is false, I leave you to ponder, what do you believe the shape of the Earth truly is?